Okay, in this example, we're going to use a balanced chemical equation to try to understand what happens when we have certain amounts of starting material. How much starting material do we need of the other component, and how much do we need of everything else? How much do we get? So the first thing is we want to always balance our equation, and so we can actually begin to balance our equation. We'll write things out. So we have iron, oxygen, and carbon. Okay, and so on this side we have the following. Over here we have 4 oxygens, 1 carbon, and 2 irons. So the irons we can essentially leave alone because they will be pretty easy. For the carbons, those will be a little bit easier, but not quite as easy. So you'll notice that we can't increase this by 2. So if we were to have done that, we'll end up with an unbalanced oxygen equation. So I'm going to go ahead and start with 3 here for carbon dioxide. So we'll end up with 3 carbons and 6 oxygens. If we were to consider over here using a multiple of 3 as well, because that will balance our carbon, we will now have the 3 oxygens here plus the 3 oxygens here, which is 6. We still have 2 irons, and then we can return to use 2 here. And so now we have a fully balanced chemical equation. So we should rewrite our equation of Fe2O3 solid plus carbon monoxide, which is a gas. There are 3 of those. They yield 2 moles of iron solid plus 3 moles of CO2 gas. Okay, now that we have a balanced chemical equation, we can move on to the next step. So we want to calculate the number of grams of carbon monoxide that can react with 0.350 kilograms of iron 3 oxide. Okay, so in this case, we're going to convert kilograms to grams to moles, and then we'll use our molar ratios from the empirical formula or from the balanced chemical equation to calculate the grams or the moles and then the grams of carbon monoxide. So to do that, we'll take our 0.350 kilograms of Fe2O3, and we're going to convert that to moles using the molar mass, which don't forget, we just sum up all of these masses. Well, we're going to do that in a second. First, we're going to convert kilograms to grams. So in 1 kilogram, there are 1,000 grams. Now we're going to use the molar mass, which is 159.7 grams in 1 mole of Fe2O3. Now we're going to convert moles of Fe2O3 to moles of CO using the balanced chemical equation. So for every 1 mole of Fe2O3, there are going to be 3 moles of carbon monoxide. This is from the equation. Okay, that's where that came from. So then we're going to convert to grams because it asks how many grams of carbon monoxide using the molar mass, and 1 mole of carbon monoxide, which weighs 28.01 grams. So now if you follow your units, you go from kilograms to grams, grams to moles, moles to moles, moles to gram. Okay, when we plug this into our calculator, we get 184.16 grams of carbon monoxide. Oh, we need to make sure that our significant figures are being observed here. And so if we use our sig figs, there are 3 found in this problem, so we will only have 184 grams of carbon monoxide. Okay. So in this case, now we want to calculate the products. So we want to calculate the grams of iron and the grams of CO2 formed from the same 0.35 kilograms of iron 3 oxide. So we're going to set it up very similarly as before. So we'll take our 0.350 kilograms. We're going to go ahead and convert that to grams. There are 1,000 grams in 1 kilogram. Now we're going to convert to moles using the molar mass that we already calculated. So it's 159.7 grams in 1 mole of Fe2O3. Now we're going to use the molar ratios that come out of our balanced chemical equation. So for every 1 mole of Fe2O3, there are 2 moles of iron. So then we want to convert this into grams, so we get the number of grams. So in 1 mole of iron, there are 55.85 grams. So then we can plug this into our calculator and we get 245.26 grams. Using our sig figs, we get 245 grams of iron. Okay, now for the other one, we want to calculate the CO2. We're going to set it up pretty much just the exact same, except it's different out here at the end. So we have 0.350 kilograms. We're going to again convert to grams. In 1 kilogram, there are 1,000 grams. Okay. Next, we're going to convert to moles of iron oxide. There are 159.7 grams. Now we need to convert using our mole ratio. So we'll go back to our balanced chemical equation, and we see that for every 1 mole of iron 3 oxide, there are 3 moles of carbon dioxide. Okay. Now we're going to use the molar mass, which is in 1 mole of CO2, there are 44.01 grams of CO2. Now that's going to equal 289.37 grams. We want to make sure we use our significant figures, which should again still just be 3. So there are 289 grams of CO2 produced. So when we are asked how to convert from a reactant or a product to the other side, we will convert from grams to moles, and then we'll use the stoichiometric numbers from our balanced chemical equation to convert to moles of the other. Then we will again use the molecular weight to convert back from moles to grams.